Okay, thank you.
All right, so Jorge, Preciado, welcome, and you're presenting for your colleague, Cristina García Vásquez. I'll let you take the floor.
Okay, thank you. Good morning, everyone. My name is Jorge Preciado. Unfortunately, Cristina Garcia was unable to make it because she's traveling to the United Nations Water Conference in a year. But today I am going to be presenting her research. And then I work for the New Mexico Water Resources Research Institute. We both work on the Mesilla Aquifer. And I'm currently working on recharge estimation from irrigated fields in the aquifer. Today, we will be talking about the Conejos Meadanos Transboundary Aquifer and the current situation of the aquifer between Mexico and United States, which is an important topic for New Mexico Water Resources Research Institute, as you may know. She has done research in this area, and she prepared this informative presentation for us. I will be walking you through the slides and discussing the key points that she wanted to share. I'm not an expert in this area, but I have worked with Ana Garcia, and if you have questions or want to be in contact with her, she will be happy to answer by email that I'm going to, well, here is her email, but at the end of the presentation, you'll get a chance to get the email and send her the questions. The water cycle, which is a natural process of water between Earth's surface and atmospheric interactions. Recharge is known as the process where water molecules goes through the hydrological cycle until deposited in the aquifer. We have here in this slide the different components. We have evaporation and transpiration, which is ET, condensation, precipitation, infiltration, and finally recharge, when these water molecules are deposited in the system, groundwater. Recharge is a key component to maintain sustainability and life of aquifers, therefore our life in the future. In groundwater exists lateral movement of groundwater, which is displacement of water. This movement of water could recharge or replenish water in other aquifers by the flow of groundwater moving in the direction of the cone of depression formed by the extraction of water in the wells. Here on this slide, you can see the International Groundwater Resources Assessment Center in 2015, which identified 366 transboundary aquifers. So significant input to the updated 2021 maps includes contribution from TAP, which is the Transboundary Aquifer Assessment Program, and 468 identified transboundary aquifers. Here we have a map of the area of study. The water, the availability of water in the region of New Mexico, Chihuahua, and Texas, which are the 3 states that share the aquifer, is limited to the transboundary aquifers of Hueco Bolsón or Valle de Juarez in Mexico, and Mesilla Conejos Meadanos, as well as the surface recharge from the Rio Grande. Groundwater in this region is a key factor for the development of life in these cities, which are mainly supplied with it. So in New Mexico, we depend on Mesilla Aquifer to provide water to mainly to agriculture, but also to the municipality of Las Cruces and also the industry. And on the Mexican side, Conejos Meadanos Aquifer have been pumped since 2010 as an alternative and supplemental source, mainly to supply water to the Juarez community industry and also for agriculture in the Valle de Juarez in Mexico. This aquifer is critical for us because although on the New Mexico side, we have some recharge from the Rio Grande and also from agriculture. On the Mexican side, we basically have little recharge. So for this project, Ana focused on the Conejos Meadanos Aquifer, which is across the border in Mexico, is an extension of the Mesilla Aquifer, as you can see here in the map, the Mesilla Aquifer in the bottom part of the aquifer in the Mexican side. It's called Conejos Meadanos. Here on this slide, I'm gonna talk briefly about the isotopes and what are they used for. So isotopes are elements that have the same number of protons but a different number of neutrons. So their atomic mass will vary depending on the difference in masses, and this will allow us to differentiate one isotope from another. And isotopes in hydrology are useful depending on the isotope we analyze, and we can obtain different information such as water age, origin, water movement, and also geological structure. So in this research, she measured the tritium isotope. This is a radioactive isotope that has half of life of 12.3 years, which it tells us that if we have tritium content in the samples from wells or groundwater, or water will be new or renewed, indicating that there is a recharge in the aquifer. She also took samples for the deuterium-18 oxygen, which is a stable isotopic combination that results was compared with previous results in the north of the Conejos Meadanos and samples in the Hueco Bolson. And 3 groups of results were compared versus the Rio Grande water line. Here on the next slide on results, it shows the study conducted in the south part of the aquifer in Juarez City in Chihuahua, Mexico. This work was done with a collaboration between the Autonomous University of Juarez City, Universidad Autónoma de Ciudad Juárez, the Municipal Water and Sanitation Board of Juarez, which is the Junta Municipal de Agua y Saneamiento, New Mexico State University, and the New Mexico Water Resources Research Institute. So no tritium content was found in the samples, which indicates that there is no recharge in the Mexican part of the aquifer.
Just to be clear to everybody, recharge means that there's no available new water on the Mexican side, correct?
Yes, yes, thank you for clarification. Here we can see the results, the isotopic results and the comparison versus previous studies in the United States were published in the article of investigation of the origin of Hueco Bolson and Mesilla Basin aquifers, US and Mexico, with isotopic data analysis in the MDPI Water Journal. As part of the results, through the determination of the radioactive isotope of tritium, they did not find significant tritium content, which means that does not exist recharge in this area. And according to other authors and Anna's results, water present in both aquifers belong to the same system in the Quaternary age. So here on this slide, we can see that as part of the expansion of the research work, she's seeking to know what's the amount of water that is moving to replenish the water in the aquifer due to cone of depressions that they present. So the second method in the estimation of recharge through the dynamics of aquifers with data on wells. On the left down corner figure, you can see in these maps the contour lines from the dynamic levels of the wells. The groundwater flux in the Conejos Meadanos well field is caused by drawdowns in the area, and as you can see, the flow is from the south to the northeast. On this slide, she's using the water balance equation with extraction data and volume pumped in wells to estimate the amount of water in the area. The estimated recharge in this aquifer was based on drawdown data, which was provided by the Junta Municipal de Aguas in Ciudad Juarez, the Municipal Board of Water and Sanitation of Ciudad Juarez. It is important to mention that the estimated recharge presented is from the same system in this aquifer system. We do not have other sources of recharge. And also infiltration recharge is minimal, so it's not considered in this equation. In the water balance equation, we'll see that drawdown change, which is BP. Drawdown change is going to be equal to the area and multiplied by the water table level, which is the change in volume pumped, and SY is the specific capacity of the aquifer or specific yield, and R is precipitation, and 1 minus EF is the irrigation. So there's no irrigation in this area, so this component is not negligible. The intersection line in the graph is recharge. So she's working on this method, and she made a preliminary estimate of 3-year cycle, which is the one being presented. And the result of the storage coefficient is the one found in the area below the 2 points. It is the amount of recharge in 3 years. We can also see that the pumping volume has increased. So as previous results, the average water replacement is 1.34 million cubic meters per year in a 3-year period from December 2011 to June 2017. And the results obtained from this project translate into the drawdown presented in the aquifer could induce an internal water movement. So work is in progress to determine recharge versus water withdrawal in this area. And
again,
it is
to be clear, Jorge, because I'm not sure everybody necessarily is a water expert here. What we're saying, what I'm hearing is that the drawdown being that much more significant, and this is due to the increase in population in Ciudad Juarez, which is 2 million people now in the metro area, because they're drawing down more than the recharge ability, we're going to go into a situation where there's not going to be enough recharge for that amount of population, just to be clear.
Yeah, that's correct. Thank you.
Okay.
And on the last slide on the conclusions, she wanted to share that the Conejos Meadanos aquifer resource is limited, since the only recharge comes from the border area, and the depletion in the wells can cause lateral recharge, which is what you just mentioned. So it is not recharge, it's not it's just displacement of the water. So in the future, problems may arise in the border area of Santa Teresa here in New Mexico. And this aquifer is not an abundant source, and people need to stop thinking like that. And I think that's all. And
can you go back, if that's the only element? We'll put her email again in the chat. Can you go back to the map at the beginning, just to show the areas where? There we go. So last year, the president of Mexico made a public call out for the major brewers. It's a big industry in Mexico, big export industry, beer, to stop using water near Monterey. Maybe you can show folks on the map where Monterey is, because Monterey was going into severe water drought, and it's going to keep going. And is this also, Jorge, an issue with transborder aquifers not sharing data, just to be clear for everybody listening, for Monterey? Because Monterey is another aquifer, it's not the same one.
No, it's another aquifer. And yeah, Monterey went into a dry period, and that causes like a limited water availability. Here in Juarez, at this moment, we don't have any we go to dry periods and then wet years, and
Right.
Dry periods it fluctuates, but there's no really like a problem that the government has stopped like pumping water because of the limited water availability.
Okay. But can you show on the map where Monterey is relative to this aquifer?
Can you see the cursor?
Yes, yes, we can see your cursor.
Oh, okay.
Yeah.
So here is in the state of Nuevo León. It's
Right.
should be somewhere in here.
Okay. So it is more or less linked to this aquifer system.
Yes, it's in the Rio Grande watershed. Yeah.
Okay, wonderful. And again, this is a major issue because it did get some media coverage, but I don't think it went into detail as to why. And what I'm understanding from this presentation and from my previous conversations with Ana Cristina is that there is a lack of data sharing between Texas and Mexico. And I was making the point earlier that Servier and USAID are funding wonderful research that Farouk showed was making progress in Southeast Asia, yet there seems to be a lack of cooperation, which maybe you can detail as to why in this data sharing between the countries. And Farouk, maybe you want to speak to that if you have some data to share or insights.
I can share this thing that we do have missions that actually measure, groundwater levels. This is the GRACE mission, and we've used them in South and Southeast Asia. So what surprises me, I don't know what type of technology is in place to measure the amount of water and with respect to water resource management. But what I can do is I can connect you to the Servier group and see, let them have an overview and have a discussion with you as to how that information, which is freely available, could be used by Mexico, for example, as a way to understand the levels of water, that are out there, and work with the, again, U.S. government, because again, this is U.S. data, it's freely available.
That's right.
And that in that way, open that channel for sharing of information. So Frederick, if you connect me to Jorge, I can definitely,
of course,
pass this on to the Servier team, and then you can potentially, they have told me to engage anybody, and so they have been serving Latin America for a long time, and so this would be a great
and we're going to go one step further, and I've mentioned this to Sam Fernald from the New Mexico Water Resources Institute. Part of the New Mexico senatorial delegation, so there are two senators. One of them is Senator Heinrich, who's an engineer by training. So he gets this. He is very much interested, I'm told, in water-related issues. And after this conference, we've been talking about making sure these connections are made, and that, for instance, Farouk, your work with Servier can be used by Senator Heinrich to say, look, we're going to provide part of the solution, because it doesn't make sense that it's not there. I mean,
it's available. It's something that can bring a lot of clarity to the situation. Right. Both partners can work with each other on a commonly agreed upon data sharing protocol. And again, that way, the discussions could be quite rational versus,
of course,
just no discussion at all, or
no,
and
again,
all this,
And again, I'm purposely looking at one of the political leaders who's an engineer by training, so that we can appeal to that side of things versus, pure politics.
Yeah, absolutely, absolutely.
Okay, so we have a bit of time until the next presentation. Thank you very much, Jorge, for stepping in so fast in your colleague's stead. If there are questions, comments, please put them in the chat or the Q&A. So what I just talked about, again, is this triple helix, where we're bringing forward-looking research, Farouk's research, and connecting it to political leadership, and we can do that throughout the world, and we can enhance it with civil society pressure and civil society's help through various organizations that we're either directly members of or we can be connected to. So I'm trying to put into practice this triple helix that I mentioned: academia, civil society and industry, and political leadership. So if there are questions, comments, things people want to share, those who are with us, please do. And Jorge, I want to thank you again for being available to share this great research. And again, ask the question, as when I first heard this, and I mentioned it to Farouk, everything's there. What's missing? It looks like not a lot.
Thank you, and I try to explain what Ana has been done in Ciudad Juarez in cooperation with also New Mexico to make this collaboration between the two countries.
Wonderful. Thank you very much. Thank you. So if you can stick around, if there are questions, please do. If not, I'll let you go, and we can potentially start the next session early, because it's a recorded session that we're going to play before Professor Hafez is available for Q&A. So if there are no questions, I'm going to stop the recording for now.